We're going to see about the unit 4. In the unit 4, you're going to see the today topic is about TCP. Here in this unit 4, you're going to talk about mobile transport and application layer. Here in this unit, we are going to see about the mobile TCP, WAP architecture, WT, WTS, WP, WSP, WAE, WT architecture, WMN and all. But today we are going to see about only the introduction about your mobile TCP. So mobile TCP LAN layer is nothing but it's a mobile transport layer. Here we are going to see about the motivation and what are the transport layer mechanisms we are going to use it. And it can be an indirect TCP, snooping TCP, mobile TCP, then fast retransmit recovery, transmission freezing, selective transmission or transaction oriented TCP. So first thing, what is the need of a transport protocols? Why it has been designed? It has been designed for a fixed end system and fixed or wireless network. Then it can able to provide your research activities, performance, congestion control, efficient retransmission. The TCP congestion control is nothing but packet loss in a fixed network due to the overlay of a network. So whenever we are going to make a fixed network, sometimes a mobile node can have an either 2 or 3 networks on the same time as a fixed network. On that time, the routers have to discard the packets. Once the routers has discarded the packet, then the next data can be added there. But once it not be happen, then maybe some packets of the data may be discarded. That will lead to your TCP congestion control. And then and it is an TCP kind of slow start algorithm. So whenever you are going to calculate a congestion window, for example, I'm going to send a packet over the network. On that time, I'm going to keep some time for each and every packet. You'd have to wait, and then only it have to come. Because we are keeping a condition window here, it have to equal to the one segment. How many segments you are going to keep it? So that segment time you should be given for that window. The window will be closed. If an encryption release will be there, then the missing acknowledgement will be happen. Then the condition will start again with the another segment, and it can able to TCP can able to provide with a fast retransmit or fast recovery. You are going to send acknowledgement only after receiving packet, and you are going to send a receives and several acknowledgements of the same packet. And if it's indicated on all the packet, then we're going to send it. Then influence of your mobility on the TCP mechanism. You are going to assume the congestion is when packets are dropped. And you are going to see about the mobility itself can cause the packet loss and the mobile node roams from one point to another point. The performance of an unmodified is a TCP degrades severe and it's going to provide the whole growth together. Then proposals to modify your work in the mobile environment. Here we are going to keep on some of the approach here. It's an indirect approach, snooping approach, YAM approach, fast transmit or fast recovery, transmission time, out freezing, selective transmission, transmission oriented TCP. In an indirect TCP, we are going to segment the connection. We are going to segment the connection. No changes for the basic TCP protocol for the host connection of the wire network. Then you're going to optimize your TCP protocol for the mobile host, also splitting your TCP connection, and we are going to see that wired and wireless network. Then in an indirect TCP2, what are the advantages means? No changes in the fixed network. There is no changes in the host is necessary, and the transmission in the wireless network does not propagate into the fixed network. Also, disadvantage lose to end-to-end semantics and high latency possible due to the buffering of data. Then snooping of your TCP1. Here the buffering of packets sent to the mobile host and lost packet of the wireless data can be done. The foreign agent snoops your packet flow and recognize acknowledgement in both the directions. It also filters or acknowledgement basic. Then the data can be transferred to the mobile host and from the mobile host and the integration of the MAC layer and also problems also. In the mobile TCP, you're going to split your mobile TCP as an ITCP and you're going to provide your supervisory host advantages and disadvantages also. Then we have a fast retransmit or read recovery. Here you are going to make a TCP react with a slow start, although there is a no condition. But some of the time you need to have a fast transmit or fast recovery. On that time, you can able to provide a new foreign agent and the MH sends a duplicate acknowledgement on the purpose. Then you are going to resend your data and there will be no mixture of IP and TCP on this approach. Transmission or timeout freezing. Here the freezing time will be there. You can able to detect your uninterpreted data and also schemas data is dependent and you're going to provide your change and mechanism layer. Then selective retransmission. Here you're going to make your cumulative one and selective retransmission of one solution and you're going to provide a higher efficiency. Then transmission oriented TCP. The TCP phases Also, we are going to provide your efficiency which require. And this is a comparison of your different approach. See, you can see the different approach comparison along with the advantages and disadvantages here. Thank you.